Welcome to this lecture, one quadratic equations. In this lecture, we will discuss NCERT Exemplars problem on quadratic equations. Okay, so let us start. So in first question here, we have to check whether this equations is a quadratic equation or not. Okay, which of the following is a quadratic equations, that we'll have to check here. So among these four options, which actually is a quadratic equation, that we'll have to here find. Okay, so let us find. So here an equation which is of the form ax square plus bx plus c, this is equal to 0, where a does not equal to 0, is called a quadratic equation. Okay, so simplify the part of the question. So basically we have to simplify the part of this question and check whether it is in the form of ax square plus bx plus c is equal to 0, where a does not equal to 0 or not. Okay, so first check option number A. Sorry, here we first check option number A. So here given that x square plus 2x plus 1, this is equal to 4 minus x whole square plus 3. Okay, so now if we simplify this equation, then we can imply it x square plus 2x plus 1, this is equal to 16 plus x square minus 8x plus 3. Basically here we use this formula a minus b whole square, that is equal to a square minus 2ab plus b square. Okay, so after using this identity here, we can simplify the right hand side and we get 16 plus x square minus 8x plus 3. Okay, and if we further simplify it, then it implies 10x minus 18, this is equal to 0. Okay, so it implies 10x minus 18 is equal to 0, and this is not of the form ax square plus bx plus c is equal to 0, and where a not equal to 0, thus the equation is not a quadratic equation. Okay, so this equation in option A, this equation is not a quadratic equation. Now let us check option number B. So in option number B, we have given minus 2x square. This is equal to 5 times 5 minus x times 2x, minus 2 by 5. Okay, and it implies minus 2x square, this is equal to 10x minus 2x square minus 2 plus 2x by 5. Okay, and it implies 50x plus 2x minus 10, this is equal to 0, and it implies 52x minus 10, this is equal to 0. Okay, and this equation is not of the form ax square plus bx plus c is equal to 0, where a not equal to 0. Okay, so the given equation in option B, this is not a quadratic equation. And now let us check option number C. So in option number C, we have given x square times k plus 1 plus 3 by 2 times x is equal to 7. Okay, and given k is minus 1. Okay, so it implies x square times minus 1 plus 1 plus 3 by 2 x, this is equal to 7, and it implies 3x minus 14, this is equal to 0. Okay, and this equation is not of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, so this equation in option number C, this is not a quadratic equation. So now let us move to option number D. So in option number D, we have given that x cube minus x square, this is equal to x minus 1 whole cube. Okay, so here basically we can expand in right hand side this expression x minus 1 whole cube as x cube minus 3x square times 1 plus 3x times 1 square minus 1 cube. That is actually, basically here we use the identity x minus y whole cube, that is equal to x cube minus 3x square times y plus 3xy square minus y cube. Okay, and now if we simplify, then it implies x cube minus x square, this is equal to x cube minus 3x square plus 3x minus 1. Okay, and it implies 2x square minus 3x plus 1, this is equal to 0. Okay, and clearly this equation is of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, so this equation represents a quadratic equation because it has of the form x square plus bx plus c is equal to 0. Okay, so therefore option number D is here correct answer. Okay, so option number D is here correct answer. So this is our correct answer. Okay, so now let us move to next question. So in next question here we have to do which of the following is not a quadratic equation. Okay, so let us check option by option. So in option A we have given 2 times x minus 1 whole square. This is equal to 4x square minus 2x plus 1. And in option number B we have 2x minus x square. This is equal to x square plus 5. Okay, and in option number C we have given root 2 times x plus root 3 whole square. This is equal to 3x square minus 5x. Okay, and in option number D we have given x square plus 2x plus x square plus 2x whole square. This is equal to x to the power 4 plus 3 plus 4x square. So let us check among these 4 options which option actually is not a quadratic equation. Okay, so here in option number B we have given 2 times x minus 1 whole square. This is equal to 4x square minus 2x plus 1. Okay, and it implies 2 times x square plus 1 minus 2x. This is equal to 4x square minus 2x plus 1. And it implies 2x square plus 2 minus 4x. This is equal to 4x square minus 2x plus 1. And it implies 2x square plus 2x minus 1. This is equal to 0. Okay, and this equation represents a quadratic equation because it is of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, so according to the question, basically we need a equation which is not a quadratic equation. But in option A we have this equation. This equation is a quadratic equation. Okay, so this is not a correct answer. This is incorrect answer. And now let us check option number B. So in option number B here we've given that 2x minus x square. This is equal to x square plus 5. Okay, and it implies 2x square minus 2x plus 5. This is equal to 0. And which also represents a quadratic equation because it has of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, and now check option number C. In option number C we have given that root 2x plus root 3 whole square. This is equal to 3x square minus 5x. Okay, and it implies 2x square plus 3 plus 2 times root 6 times x. This is equal to 3x square minus 5x, and it implies x square minus 5 plus 2 times root 6 times x minus 3, and this is equal to 0. Okay, so which also represents a quadratic equation because it has of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, so now let us check option number D. So in option number D here we have given that x square plus 2x whole square. This is equal to x to the power 4 plus 3 plus 4x square. Okay, so now we can use the identity a plus b whole square. This is equal to a square plus b square plus 2ab. Okay, so if you use this identity, then we basically get x to the power 4 plus 4 times x cube plus 4x square. This is equal to x to the power 4 plus 3. Okay, x to the power 4 plus 3 plus 4x square. And it implies minus 4x square plus 4x cube. This is equal to x to the power 4 plus 3 plus 4x square. And this implies 4x cube minus 3. This is equal to 0. And this equation is not of the form ax square plus bx plus c is equal to 0, where a does not equal to 0. Okay, so thus the equation is not a quadratic equation. So basically this equation is a cubic equation. So according to the question here in option number D we have this equation, and this equation is not a quadratic equation. Sorry, this equation is not a quadratic equation. So here the correct answer is option number D. Okay, so I think this is clear to you. So now let us move to question number 3. So here in question number 3, here which of the following equation has 2 as a root? Okay, so we have given 4 equation in 4 options. So we have to check among these 4 equation which equation actually has 2 as a root. Okay, so let us check. So we know this concept. if alpha is one of the root of any quadratic equation, that is f of x is equal to ax square plus bx plus c is equal to 0, then x is equal to alpha, that is alpha satisfies the equation, that is a alpha square plus b alpha plus c is equal to 0. Okay, so now if we substituting the value of alpha is equal to 2 in option number A, then so if we substitute x equal to 2 in option number A, then we get 2 square minus 4 times 2 plus 5. This is equal to 4 minus 8 plus 5, that is equal to 1, and this is not equal to 0. Okay, so x is equal to 2 is not a root of x square minus 4x plus 5 is equal to 0. Okay, so this is not a root of this quadratic equation. Now in option B, here we substituting the value of x is equal to 2 in x square plus 3x minus 12. Okay, then we get 2 square plus 3 times 2 minus 12, that is equal to 4 plus 6 minus 12, that is equal to minus 2. This is not equal to 0. So x is equal to 2. This is not a root of x square plus 3x minus 12 is equal to 0. And now let us check option number C. So substituting the value of x in x is equal to 2 in equation in 2x square minus 7x plus 6, then we get 2 times 2 square minus 7 times 2 plus 6. This is equal to 2 times 4 minus 14 plus 6. Okay, and this is equal to 8 minus 14 plus 6, that is equal to 14 minus 4, 14, that is equal to 0. Okay, so x is equal to 2, if x is equal to 2 satisfied the equation 2x square minus 7x plus 6. Okay, so x is equal to 2 is a root of the equation 2x square minus 7x plus 6 is equal to 0. So here the correct answer is option number C. So now you can check also option number D. So if we substitute x equal to 2 in 3x square minus 6x minus 2, then you will get that is equal to minus 2, and this does not equal to 0. Okay, so x is equal to 2 is not a root of 2x square minus 6x minus 2 is equal to 0. Okay, so now let us move to question number 4. So in question number 4, here we have if 1 by 2 is a root of the equation x square plus kx minus 5 by 4 is equal to 0, then the value of k is what? Okay, so we need to find the value of k. So basically we have given 1 by 2, this is our root of x square plus kx minus 5 by 4 is equal to 0. So since 1 by 2, this is our root of the given equation, then put x equal to 1 by 2 in given equation, then we get the value of k. Okay, so since 1 by 2 is a root of the quadratic equation x square plus kx minus 5 by 4 is equal to 0, then 1 by 2 square plus k times 1 by 2 minus 5 by 4, this is equal to 0. Okay, and it implies 1 by 4 plus k by 2 minus 5 by 4, this is equal to 0, and it implies 1 plus 2k minus 5 by 4, this is equal to 0, and it implies 2k minus 4 is equal to 0, and it implies 2k, this is equal to 4, and it implies k is equal to 2. Okay, so k is equal to 2. So the value of k is 2. Okay, so if 1 by 2, this is a root of the equation x square plus kx minus 5 by 4 is equal to 0, then the value of k is 2. So here the option number A is correct answer. Okay, so now let us move to question number 5. So which of the following equation has a sum of its roots as 3? Okay, so we have given 4 equation in 4 options. So among these 4 equation, which equation has the sum of its root as 3? Okay, so let us check. So if we know this concept, if alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0, a does not equal to 0, then the sum of the zeros, sum of the roots, that is equal to alpha plus beta, this is equal to minus of coefficient of x by coefficient of x square, that is equal to minus of b by a. Okay, so we have given that in option A 2x square minus 3x plus 6 is equal to 0. So one comparing with ax square plus bx plus c is equal to 0, then we get the value of a is 2, value of b is minus 3, and value of c is 6. Okay, so therefore the sum of roots, that is equal to minus b by a, and this is equal to minus of minus 3 by 2, and this is equal to 3 by 2. So the sum of roots of the quadratic equation 2x square minus 3x plus 6 is equal to 0 is not 3. Okay, so it is not the answer. And now let us check option number B. So in option number B, here we given that minus x square plus 3x minus 3, this is equal to 0. Okay, so one compare with ax square plus bx plus c is equal to 0, then we get the sum of roots, this is equal to minus b upon a, and this is equal to minus 3 by minus 1, and this is equal to 3. Okay, so sum of roots of the quadratic equation x minus x square plus 3x minus 3, this is equal to 0 is 3. Okay, so option number B is the answer. Okay, so now you can check option number C. So here we have given root 2x square minus 3 by 2 times 3 by root 2 times x plus 1, this is equal to 0. And now you can simplify this, and it implies 2x square minus 3x plus root 2, this is equal to 0. And when comparing with x square plus bx plus c is equal to 0, then we get the value of a, this is 2, b, this is equal to minus 3, c is equal to root 2. Okay, and therefore sum of roots, this is equal to minus b upon a, and this is equal to minus 3 by 2, and this is equal to 3 by 2. So sum of the roots of the quadratic equation root 2x square minus 3 by root 2x plus 1 is equal to 0 is not 3. Okay, so it is not the answer. And now let us move to option number D. So in option number D, we have given 3x square minus 3x plus 3 is equal to 0. Okay, so it implies x square minus x plus 1 is equal to 0 when comparing with the general form of quadratic equation ax square plus bx plus c is equal to 0, then we get a is 1, b is minus 1, and c is 1. Okay, so therefore the sum of the roots, this is equal to minus b upon a, and this is equal to minus of minus 1 by 1, and this is equal to 1. Okay, so the sum of the roots of the quadratic equation 3x square minus 3x plus 3 is equal to 0 is not 3. Okay, so it is not the answer. So here the correct answer is only option number B. Okay, so here option number B is only the correct answer. So this is our correct answer. So option number B is here correct answer. And now let us move to question number 6. So here we have to find the value of k, for which the quadratic equation 2x square minus kx plus k, this is equal to 0 has equal roots. That is we have to, if we know this formula, if and quadratic equation ax square plus bx plus c is equal to 0, a does not equal to 0, has two equal roots, then its discriminant should be equal to 0. Okay, so discriminant d, this is equal to b square minus 4ac, that is equal to 0. And here given that 2x square minus, in option D we have given 2x square minus kx plus k, this is equal to 0, and one comparing with ax square plus bx plus c is equal to 0, we get a is 2, b is minus k, and c is equal to k. Okay, and for equal roots the discriminant must be 0, so therefore d is equal to b square minus 4c is equal to 0, and it implies minus k whole square minus 4 times 2 times k, this is equal to 0, and it implies minus k square minus 4 times 2 times k, this is equal to 0, and it implies k square minus 8k, this is equal to 0, and it implies k times k minus 8, this is equal to 0, and therefore the value of k is equal to 0 and 8. Okay, hence the required values of k are 0 and 8. Okay, so here in option D we have the value 0 and 8. So for this question here correct answer is option number D. Okay, so I think this is clear to you, so we can now move to next question. Okay, so let us move to next question, that is question number 7. So it said to us which constant must be added and subtracted to solve the quadratic equation 9x square plus 3 by 4x minus root 2 is equal to 0 by the method of completing the square. Okay. So let us find the constant that must be added or and subtracted to solve this quadratic equation by the method of completing square. So given equation is 9x square plus 3 by 4x minus root 2 is equal to 0. Okay, so 3x whole square plus 1 by 4 3x minus root 2, this is equal to 0. And 1 footing 3x is y, we have y square plus 1 by 4 y minus root 2 is equal to 0. Okay, and it implies y square plus 1 by 4 y plus 1 by 8 whole square minus 1 by 8 whole square minus root 2, this is equal to 0. And it implies y plus 1 by 8 whole square, this is equal to 1 by 64 plus root 2. Okay, and it implies y plus 1 by 8 whole square, this is equal to 1 plus 64 times root 2 is equal to 64. Okay, so thus 1 by 64 must be added and subtracted to solve the given equation. Okay, so here basically we have to 1 by 64 must be added and subtracted to solve the quadratic equation by the method of completing the square. So here the option number B is correct answer. Okay, so now let us move to question number 8. So in question number 8 we have this quadratic equation, and the quadratic equation has which type of roots. Okay, so let us check. So we have given this quadratic equation, and we can think like this process. So if a quadratic equation is in the form ax square plus bx plus c is equal to 0, where a does not equal to 0, then if d is b square minus 4ac that is greater than 0, then its roots are distinct and real. Okay, so d is b square minus 4ac that is greater than 0, so then its roots are distinct and real. And if d is b square minus 4c is equal to 0, then its root are real and equal. Okay, and d is b square minus 4ac, then its roots are not real, or the roots are actually imaginary roots. So any quadratic equation must have only two roots. Okay, so in given equation we have 2x square minus root 5x plus 1 is equal to 0. So one comparing with ax square plus bx plus c is equal to 0. Here we get a is 2, b is minus root 5, and c is equal to 1. Okay, and the discriminant d, this is equal to b square minus 4ac, that is equal to minus root 5 whole square minus 4 times 2 plus 1, that is equal to 5 minus 8, and this is equal to minus 3, and this is less than 0. Okay, so since the discriminant is negative, therefore the quadratic equation 2x square minus root 5x plus 1 is equal to 0 has no real roots. That is it has imaginary roots. Okay, so the quadratic equation has no real roots. That is here option number C is correct answer. Okay, so now let us move to question number 9. So here which of the following equation has two distinct roots? Okay, so we have to check. We have given this equation, and which of the following equation has two distinct real roots, that we have to check. Okay, so given equation is x square plus x minus 5 is equal to 0. Okay, and one comparing with ax square plus bx plus c is equal to 0, we get a is 1, b is 1, and c is equal to minus 5. Okay, so the discriminant of x square plus x minus 5 is equal to 0 is d is equal to v square minus 4ac, that is equal to 1 square minus 4 times 1 times minus 4, that is equal to 1 plus 20, that is equal to 21. Okay, and it implies d, that is equal to b square minus 4ac, is greater than 0. So x square plus x minus 5 is equal to 0 has two distinct real roots. Okay, and in option B, so the option number B is here correct answer. So this option is here correct answer. So obviously this is our only correct answer question. Okay, so other option must be incorrect. So here only correct answer is option number B. And now let us move to question number 10. So in question number 10, here we have to check which of the following equation has no real roots. Okay, so let us check. So here the given equation is x square minus 4x plus 3 times root 2, this is equal to 0. And when comparing with ax square plus bx plus c is equal to 0, here we get a is 1, b is minus 4 and c is equal to 3 times root 2. And the discriminant of x square minus 4x plus 3 times root 2, this is equal to 0, is d is equal to b square minus 4c, that is equal to minus 4 whole square minus 4 times 1 times 3 times root 2. This is equal to 16 minus 12 times root 2, that is equal to 16 minus 12 into 1.414. Okay, and this is equal to 16 minus 16 minus 92, that is equal to minus 0.92. Okay, so here discriminant d is minus b square minus 4c, this is less than 0. So this list of the given equation has no real roots. Okay, so in option number A, here we have this, and this equation has no real roots. So this is our correct answer. So now you can check option number B. So the given equation is x square plus 4x minus 3 times root 2. This is equal to 0. And when comparing the equation with ax square plus bx plus c is equal to 0, we get a1. A is equal to 1, b is equal to 4, and c is equal to minus 3 times root 2. Okay, and d is equal to b square minus 4ac, that is equal to minus 4 whole square minus 4 times 1 times minus 3 times root 2, that is equal to 16 plus 12 times root 2. If this is greater than 0. Okay, hence the equation has real roots. And in option number C, here we have given equation is x square minus 4x minus 3 times root 2, this is equal to 0. And when comparing the equation with x square plus bx plus c is equal to 0, here we get then a is 1, b is minus 4, and c is equal to minus 3 times root 2. And the discriminant d is b square minus 4ac, that is equal to minus 4 whole square minus 4 times 1 times minus 3 times root 2, that is equal to 16 plus 12 times root 2, and this is greater than 0. Hence the equation has real roots. And now let us check option number D. So here we have given equation is 3x square plus 4 times root 3x plus 4 is equal to 0. And when comparing the equation with ax square plus bx plus c is equal to 0, here we get a is 3, b is 4 times root 3, and c is equal to 4. So the discriminant d is b square minus 4ac, this is equal to 4 times root 3 whole square minus 4 times 3 times 4, that is equal to 48 minus 48, and this is equal to 0. Okay, hence the equation has real roots, and hence x square minus 4x plus 3 times root 2, this is equal to 0, has no real roots. Has two equal roots. Okay, has real roots. Okay, so here only in option number A, this equation x square minus 4x plus 3 times root 2 is equal to 0 has no real roots. Okay, so here option number C is correct answer. Now let us move to question number 11. So here we have given this quadratic this equation x square plus 1 whole square minus x square, this is equal to 0. Okay, so here we can simplify this equation. So if we simplify the given equation, then it implies x to the power 4 plus 1 plus 2x square minus x square, this is equal to 0. Okay, and basically we use here the formula a plus b whole square, this is equal to a square plus 2b plus b square. Okay, and it implies x to the power 4 plus x square plus 1 is equal to 0. And now if we let x square is y, then therefore x square whole square plus x square plus 1 is equal to 0, and it implies y square plus y plus 1 is equal to 0. Okay, and here a is 1, b is 1, and c is equal to 1. And discriminant d is b square minus 4c. So this is equal to 1 square minus 4 times 1 times 1, that is equal to 1 minus 4, that is equal to minus 3, and discriminant is less than 0. Okay, so this equation has no real roots. So here the option number C is correct answer. Okay. So now let us move to very short answer type questions. So in question number 1, here we have to state whether the following quadratic equation have two distinct real roots. Okay, so justify your answer. So in first one, here we have x square minus 3x plus 4 is equal to 0. Okay, so you can find discriminant, and if discriminant is positive, then roots are real and distinct, and discriminant is 0, then roots are equal and real. Okay, and discriminant less than 0, then no real root, that is imaginary roots. Okay, so given equation is x square minus 3x plus 4 is equal to 0. So if we comparing this equation with ax square plus bx plus c is equal to 0, then we get a is 1, b is minus 3, and c is equal to 4. Okay, and discriminant d is b square minus 4ac, that is equal to minus 3 whole square minus 4 times 1 times 4, that is equal to 9 minus 16, this is equal to minus 7, this is less than 0. Okay, so discriminant d is less than 0. Hence the equation this has no real roots. And now for second one, so in second one here we given 2x square plus x minus 1, this is equal to 0. And if we compare with this, then you will get a is 2, b is 1, and c is minus 1. And discriminant d is 1 square minus 4 times minus 1, that is equal to 9, and this is greater than 0. Okay, so the given equation has two distinct real roots. And for third one, given equation this, so if you comparing this equation with this, then we get a is 2, b is minus 6, and c is 9 by 2. Discriminant d is minus 6 whole square minus 4 times 2 times 9 by 2, that is equal to 36 minus 36, that is equal to 0. Okay, so discriminant d is 0. So the given equation has two real roots and equal. Okay, so you can similarly check fourth one, fifth one, sixth one, eighth, seventh one, eighth one, 10th one, 9th one. Okay, so that is similar to. So now let us move to question number 2. So write whether the statement are true or false and justify your answers. So in first statement here we have asked every quadratic equation has exactly one root. Okay, so but we know if we have a quadratic equation ax square plus bx plus c is equal to 0, then this quadratic equation has at most two roots. Okay, so this statement is false. This is false. And now second statement, every quadratic equation has at least one real roots. No, this is not this is not necessary, because there are some quadratic equation that has actually no real roots. Okay, when discriminant is less than 0, that case quadratic equation has no real roots. Okay, so this statement is also false statement. And in third one, every quadratic equation has at least two roots. This is also false. At least two roots is not enough. Sometimes we take no real roots. Okay, so third one is also false, since the quadratic equation has two and only two roots. Okay, and fourth one, every quadratic equation has at most two roots. At most two roots. Yes, this is true, because every quadratic equation has at most two roots. And fifth one, if the coefficient of x square and the constant term of a quadratic equation have opposite signs, then the quadratic equation has real roots. So this is true, since in this case discriminant is always positive, so it has always real roots. Okay, that is AC less than 0, and so b square minus 4ac, this is greater than 0. And sixth one, if the coefficient of x square and the constant term have the same sign, and if the coefficient of x term is 0, then the quadratic equation has no real roots. So this statement is also true, since in this case discriminant is always negative, so it has no real roots, that is b is equal to 0. Then b square minus 4ac, this is minus 4ac, that is less than 0. Okay, and ac greater than 0. So student, I stop here this lecture. Thank you very much to all of you.